Hey guys, so this is lesson 2.2 and we're going to be talking about applications of linear equations. Basically, applications of linear equations is word problems where we need to use linear equations to find the solution. Okay, so on the first example, we have that Mrs. Ramirez has 26 students in her third grade class. There are 4 more boys than girls, and then they're asking us to find how many boys and girls are in her class, right? So the first thing that you always want to do when we're talking about word problems or applications is know what is the objective. What is the goal, right? That's the first thing. If we don't know how to identify the goal or the objective that we want to find, then there's really like no point of looking at the word problem, or you're basically going to be reading something without understanding what is it that you need to do. So the first thing that we have to do is identify what is the objective. So in this case, our objective is to find the number of boys and the number of girls. So that's what we need to find. Okay? So that is our objective for this word problem. Now, the next thing that I'm going to do is I'm going to go ahead and break the application or the problem apart in sentences. So my first sentence says that Mrs. Ramirez has a total of 26 students. Okay. So this first part has 26 students. So that right there means that whatever number of the boys plus whatever number of the girls, it's going to be a total of 26, right? Now the other sentence says that there are 4 more boys than girls. Okay. Now let's go ahead and first focus on the second sentence. So I'm going to go ahead and focus on this one first, and then we're going to go to the total of 26, okay? So it says there are 4 more boys than girls, right? Notice how they are relating the number of boys with the number of girls. Whatever number of girls we have, there are 4 more boys, right? 4 more than that for the boys. So let's go ahead and let x equals the number of girls. Right? We don't know how many girls are, right? So we're going to assign the variable x for the number of girls. So that means that if x is the number of girls, then 4 plus x must be the number of boys. Okay? And the reason is because it says there are 4 more boys than girls, right? So if x is the number of girls, then 4 plus x must be the number of boys. Okay? Now from after this, let's go back to the first sentence, right? Where it says that there's a total of 26 students. Now, remember that total goes back to addition. That means that the number of boys plus the number of girls equals 26. Okay, so I'm going to go ahead and write this here on the side. So that means that boys plus girls equals 26. Okay? But now we know that for boys, we have 4 plus x, right? So instead of boys, I'm going to go ahead and replace that with 4 plus x. And then we see that the number of girls is represented with x, right? So instead of girls, That was such a bad color to choose for the word girls. Let me change that. Let me put another color. It's because the I'm writing with red, so I guess I don't know if there, yeah, there are no more. So I'm gonna choose the green then. I guess the red and the pink don't really go well. Yeah, that's better. So for girls, we have the value x, right? So I'm replacing 4 plus x for boys and x for girls, right? Now I'm gonna go ahead and combine the like terms and to solve, right? So if I combine, I can see. Let's get rid of the parentheses first, just to have it more clear. I can see that I have x plus x, right? So that would be 4 plus 2x equals 26. Now I'm gonna get rid of the 4 to solve for x. So minus 4 minus 4. 2x equals 22. Divide by 2. X equals 11. So that means if x equals 11, that means that there are 11 girls. Okay? So if there are 11 girls, right, then knowing that there are 4 more boys than girls, all we have to do is plug in, right? So add 4 plus 11. So this is 11 girls. And then 4 plus x, that'll be 4 plus 11, which equals 15. So that means there's 15 boys. So we can say there are 11 girls and 15 boys in the class. Remember, we always wanted to give a final, sentence for the result. Okay? So let's go ahead and do another example on applications of linear equations. Okay. So this one says the record low temperature for the month of January in Anchorage, Alaska. I'm just gonna keep it with Alaska. Was in degrees Fahrenheit 84 degrees, less than January's record high temperature. The sum of the record low and record high is 16 degrees. Find the lowest and highest temperatures ever recorded in Alaska in January. It's really I don't know, Anchorage. I have to look it up and see how you say that. But anyways, so let's go ahead and identify again what is the goal, right? What is the objective? So that's the first thing that we want to identify. What is the objective? So my objective is to find the lowest and highest temperature, okay? Just gonna put temps. Okay, cool. So that is what we're trying to find. That is where we want to get. Now let's go ahead and break the problem into sentences. So I see that it says the record low temperature for the month of January was 84 degrees less than the high temperature. Okay, so notice how they are talking about the low temperature in relation with the high temperature, right? Because they're saying that it's 84 less than, right? So let's go ahead and write that on the side so we can say the low temperature was 84 degrees less than the high temperature. So I basically just wrote what that what that sentence says, but with less words, like just focusing on the numbers and the less than, right? And the two measurements that are being compared, which is the low temperature and high temperature. So the low temperature was 84 less than. So let's remember that the word less than means subtracted from, right? Now, we can say that this is like the is, right? Like the equal. This is just 84. High temperature, we don't know what is the high temperature. So let's go ahead and say that the high temperature is going to be X, right? So then low temperature equals whatever the high temperature is, X, minus 84. Right? Remember, we kept the 84. Because we have the low temperature is 84 subtracted from X, saying X is the high temperature, right? Let's go ahead and put like blue for X. Okay. So that is what the low temperature is. And then let's go ahead and just write, just to write it down, the high temperature is X, which is what I assigned originally. Okay. Now it says for the other sentences, the sentence, it says this, the sum of the record low and record high is 16, right? So the next sentence says the sum of the low and high is 16 degrees. So sum means plus, right? That means we're going to add. So we're going to add the low temperature plus the high temperature. So I'm going to have X plus X minus 84 equals 16. Okay. Now if I add them, now I can see that I can combine the X value. So I will end up with 2X minus 84 equals 16. Now I can add 84 on both sides. This cancels, so I end up with 2X equals 16 plus 84, which is 100. If we divide by 2, X equals 50. So what does that mean? That means that the high temperature, because the high temperature is the X, right? So remember we found X. So that means that the high temperature is 50 degrees Fahrenheit. And then the low temperature will be that value minus 84, right? So I will take X minus 84. I'm just going to put low temp. So that will be 50 minus 84. Notice how I'm just plugging in 15x, right? So 50 take away 84 will be a negative 34. So that means that the low temperature is negative 34 degrees Fahrenheit. And this will be my solution, okay? So just remember, we always gonna have one unit or one of the measurements or whatever we're trying to measure related to the other one, right? So the one, like the second one is usually the one that we assign the variable for. So for instance here, the low temperature was written, or the sentence was written from the low temperature in terms of the high temperature, because it says 84 less than the high temperature. If we would have said the high temperature is 84 degrees more than the low temperature, then X would have gone for the low temperature, right? So we have to pay attention in terms of what are we describing the units, right? Because low temperature is being described in high temperature, that's the one that's going to take the X. And then we just, translate from English to math, right, for the X minus 84. and we end up solving. Again, here we had to see, that it's at the sum, so that means a plus, right? So we ended up adding the low and the high. Okay. Let's look at this other example. So this one says that a 24 feet chain must be cut into two pieces so that one piece is twice as long as the other. Find the length of each piece of chain. For this type of problems, what I usually do is I just like to do a drawing, just to kind of like have an idea of like what is it that it's saying. So I'm just gonna go ahead and kind of like draw a chain. I'm not gonna draw a chain. I'm just kind of like gonna go ahead and draw like let's say a rectangle that's gonna represent the chain. Yeah, I'm not the best drawer, so I'm not too good at drawing. So even this rectangle might look really weird. So let's say this is a chain. Okay. So that's the chain. And then we know that the total, right? So the total distance for the entire chain is going to be 24 feet. However, they are telling us that this is going to be cut into two pieces, right? So that one piece is going to be as long as the other. So let's say it's going to be cut over here. Okay. So, we have piece number 1 and then let's say piece number 2, or piece 1 and then piece 2. So let's go ahead and write that in a sentence. Let's try to write it in simpler words. So I will say one piece is twice as long as the other piece. And also, I forgot to write down the objective, right? So for objective, we have to find length of two pieces. So we need to find two measurements, right? That's the objective. Okay. So we have one piece is twice as long as the other piece, right? So in other words, we can say that piece 1 is, so remember, is in math, it's equal, twice as long as, so that means 2 times. And then the other piece, let's say this is piece 2. Notice how the first piece is being described in terms of the other piece, right? Because it says twice as long as the other piece. So let's go ahead and say that piece 2, it's going to be x. I'm going to assign the variable x to piece 2. So then I can say that piece 1 equals 2 times x. Okay? Now, the second part of the problem says that the 24 feet chain, it's cut in two pieces. So what this means is that both pieces together create a total of 24. So that means that if we add piece 1 plus piece 2, we're going to get 24, right? So piece 1, let me change that for another color. So piece 1 plus piece 2 equals 24. Or we can say that 2x, because we mentioned before that piece 1 is 2x, right? And that piece 2 is x. So p is 1, 2x plus p is 2, which is x, equals 24. That means that 3x equals 24. If we divide by 3, x equals 8. So that means that piece 2 equals 8 feet. But now we had said that piece 1 equals 2 times piece 2, right? So here piece 1 will be 2 times 8, which is 16. So then piece 1 equals 16 feet. So that is our solution. So the two pieces of the chain are 8 feet and 16 feet. Okay. Cool. Okay, so now we're going to go to lesson 2.4, and this one has some problems that can be a little bit more complicated. If the textbook does show some other examples, if you needed to look at extra ones, if you are still having trouble with this, I will really recommend you to go to join in on the tutoring sessions in the evenings if you have a chance, or just contact me for, to schedule a tutoring appointment. Just just so just so I can go over this with you in case you need that extra help. Okay, so this is just more applications of linear equations. For this example, it says that a collection of coins consists of pennies and nickels. There are 5 fewer nickels than there are pennies. If the coins are worth a total of $4.97, how many of each type of coin is in the collection? So first thing the objective, right? So my objective is to find the number of coins and nickels. Okay? So that's what I want. That's the goal, right? That's what we need to be getting at the end of the problem. The first thing that I'm noticing, it says that there's a collection of coins that consist of pennies and nickels. There are 5 fewer nickels than there are pennies. And then it says if the coins are worth a total of $4.97, how many of each are in the collection, right? So I'm noticing that I don't really have the number for either pennies or nickels, right? So they both, I'm going to go ahead and assign a variable to each one of them. Okay, so again, I don't really know how many pennies are, and I don't really know how many nickels are. So I'm going to go ahead and assign a variable to each. So I'm going to say let P equal the number of pennies. And N equals the number of nickels in the collection, right? So that's what we're going to start with. Now let's go ahead and read the first sentence. It says there are 5 fewer nickels than there are pennies. Okay. So we begin with there are 5 fewer nickels than there are pennies. So let's break this apart. So fewer than, right? That means less than, in other words. Oops. So there are 5 nickels less than the number of pennies. So then I can say that N, so the nickels, N, let's write it with words. Nickels equals whatever number of pennies minus 5, because it's less than, right? So n equals p minus 5. Now this is an important part, okay? So we have found one equation, right? Where I said that the number of nickels equals whatever number of pennies minus 5. Because again, it says there are 5 fewer nickels than there are pennies, okay? Now let's look at the next sentence. And the next sentence says that if the coins are worth a total of $4.97. So let's write it here. So coins are worth total of $4.97. What does that mean? This right here means that the if we add the value of the nickels with the value of the pennies, they give you a total of $4.97. Here on this sentence, on this yellow sentence that I highlighted, they are merely talking about the value of the coins. They're not talking about the quantity, which is like how many coins are there. No, they're actually talking about the price value, right? So if we're talking about the price value, then we know that a nickel, we know that nickels are 0.05 cents, right? So they're 5 cents. And we know that pennies are 0.01. That means 1 cent, right? So if we're talking about what is the price value of the nickels in regards of the number of nickels that we have, then the value in the collection, again, of nickels will be 0.05 times the number of nickels. Each nickel is 5 cents. If we have 10 nickels, right, then it'll be 50 cents, right? So we have to multiply whatever number of nickels we have times 0.05 to know what will be the price value. Same thing for pennies. The value for the pennies will be 0.01 times p. Okay. And now, because we are talking about total, right, then that means that we're going to have to do some sort of addition that it's going to give us an equal of 497. So that means that if I go ahead and add, right, so let's say total value, total value will be 0.05 n, so whatever the value for the nickels plus 0.01 p, whatever the value of the pennies equals $4.97. Okay. So there we have our two equations that we're going to be working with, right? So one talks about the number of coins, right, in the collection, which is the n equals p minus 5. And then the other one talks about the number of money, right? So now like within like the price value inside of the bag or in the collection. So now what we're going to do, so now we're going to go to like, let's say step 3, now that we have broken apart the two sentences. We're going to plug in n equals p minus 5 on the second equation, okay? What do I mean by that? I'm going to go ahead and take the second equation that I got. I'm going to go ahead and do like a line right here. So I had 0.05 n plus 0.01p equals 4.97. Now notice how this right here is the value of n, right? And we also have an n right here. So by plugging in, I mean that instead of n, I'm going to go ahead and replace it with p minus 5. Okay, so this n will be replaced with p minus 5. And then I have 0.05 and then plus 0.01p equals 4.97. Okay? Now, what I'm going to do from here, notice how we have all these decimals. I really don't like to work with decimals. It's kind of like the same as fractions. The more decimals that we have, the more complicated that the problem is going to be. So what I'm going to do is I'm going to go ahead and move the decimals twice to the right for every single term. So keep in mind that whenever we are moving decimals, they need to be moved the same amount of times for every single term. So I have to move it for the 0.05, for the 0.01, and for the 4.97. So every single term on the equation, okay? So again, I am moving this twice on each. And the way that I move it twice, it's like we're multiplying by 100 each of the terms, since that's what's making the decimal point to move twice to the right. So we end up with 5 times p minus 5 plus 1p equals 497. Now from here we know what we do. We first need to distribute the 5, right? So 5 times p is 5p, minus 5 times 5 is 25, plus 1p equals 497. If we add our p values, we get 6p minus 25 equals 497. And then I'm going to be adding the 25 on both sides because I have to do the opposite from subtraction. 6p equals 497 plus 25, which is 522. And then I'm going to divide by 6. So p equals 87. Right. So that means that there are 87 pennies, right, in the collection. Now we want to find nickels as well, right? So for the nickels, I'm going to go back to n equals p minus 5. Remember, there's 5 fewer nickels than there are pennies, right? So I'm going to do the n equals p minus 5. So n equals 87 minus 5. So n equals 82. So there are I'm going to say there are, where's my, oh, here it is. There are 87 pennies and 82 nickels in the collection. And that would be my solution. Okay. Cool. Okay, let's go ahead and see this one. So this one says, how many milliliters of a 7% alcohol solution and how many milliliters of 15% alcohol solution must be mixed in order to make a 20 milliliters of a 9% alcohol solution? Okay, so again, what is the objective? So the objective on this one is to find the number of milliliters for the 7% and for the 15%. Cool. Now, notice how, we're not really explaining them, like explaining one solution related to the other one, right? We're just saying that there's a 7% alcohol solution and there is a 15% alcohol solution. So what I'm going to do is, because I don't know the number of milliliters of each, I'm going to go ahead and assign a variable for each, okay? So we're assigning variables. So I'm going to say that x equals a 7% solution, or the number of milliliters of the 7%, and y equals the number of milliliters of the 15% solution. Okay. Now there's two different things that we're talking about on this one. And the first one is, we're talking about quantity. So how many milliliters are in the solution, in the total, like the final solution. So there's going to be two equations again. One equation is for quantity. So this is like the number of milliliters in the mixture. So we know that if I combine the number of milliliters for the 7% and the number of milliliters for the 15%, it's going to give me a total of 20 milliliters at the end, right? So I know there that I had a total, at the end, a total of 20 milliliters. So that means that x, so the number of milliliters for the 7% solution, plus y, so the number of milliliters for the 15% solution, equals 20. So that is going to be my first equation. Okay. Now for the second equation, it's going to be representing the percentage. The percent of solution, okay, in each of the substances. So equation is a percent solution. So I know that x is 7%, so I can do 0.07 times x. Remember, x is the number of milliliters, so we multiply the percentage by the amount. Let's go ahead and make a note here. So percent times amount. Okay, so 7% times x, and then if we add the percentage of the other solutions, 0.15 y, right, because the y represents the amount of the 15% solution, it should give us an equal of 9% of the other, like 9% of the 20 milliliters of the other one, right? So it should equal 0.09 times 20, right? So this right here, we're talking about, or we're multiplying the percentage times each of the amount or the quantities for each of the solutions. For the 7% solution, we have X amount of milliliters, so we multiply times 0.07. For the 15% solution, we have Y amount of milliliters, and we multiply times 0.15 because it's 15%. And then for the final mixture, right, we have 20 milliliters for the 9%, so 20 times 0.09, right? So we multiply the percent times the amount of each of the solutions, okay? Now, we're going to do the same thing as the previous problem. We have to plug in one of the equations into the other one. What I'm going to do is, because the x plus y equals 20, it's way simpler than the second one. I'm going to go ahead and isolate one of the variables. So here in this one, I can say that y equals 20 minus x. So I move the x with the 20 as a negative, right? And this right here, it's what I'm going to go ahead and plug in on the second equation, okay? So I'm going to go ahead and do my work here on the side. Again, I'm looking at this equation, and I'm looking at this one right here. So I'm going to take the complicated one, and I'm going to plug in the simpler one on the complicated one. So plug in y equals 20 minus x. So I'm going to go ahead and take it 0.07x plus 0.15y equals 0.09 times 20. Okay? And again, I can see that my y value is the one that I'm going to be replacing for the 20 minus x. So I'm going to have 0.07x plus 0.15, and then I'm going to open a parenthesis. And instead of y, I'm going to write 20 minus x, and then equals 0.09 times 20, which is 1.8. Okay? So from here, what I can do, let's say we don't want to get rid of the decimals, I can just go ahead and, distribute with the decimal. So I'm going to do this a little bit different than the previous one, but you can still, move the decimals twice to the right to get rid of them. Okay, so this is 0.07x plus 0.15 times 20, which is going to be 3.0, and then minus 0.15 times x, which is negative 0.15x, equals 1.8. Okay. I have my equal sign over here, so I can go ahead and draw my line. And then I'm going to go ahead and identify my like terms, 0.07 and negative 0.15. That's going to give me a negative 0.08x plus 3.0 equals 1.8. Now I'm going to subtract 3.0 on both sides. Cancels at 3.0. We have negative 0.08x equals 1.8 minus 3.0, which is going to give us negative 1.2. Then I'll divide by negative 0.08 on both sides. So x equals 15. And the reason why it's positive 15 is because negative 1.2 divided by negative 0.8. Okay, so all of this, what I did on these steps is just basically solving the equation by moving numbers away from x. Okay, so x equals 15. Let's remember x represents a 7% solution. So we found the 7% solution. Now we need to find how much is a 15%. So for the 15%, we're going to go back to the first equation that we found, right? So that we're going to take it here, and we have that y equals 20 minus x. So this x will be replacing the x, or the 15 will be replacing the x on the equation. So y equals 20 minus 15, so y equals 5. So that means we need to mix, oops, so we need to mix the 15 milliliters of the 7% solution and 5 milliliters of the 15% solution to get, or to make, a 20 milliliter of the 9% alcohol solution. And we are done. Okay, so again, our solutions are these two: 15 milliliters of the 7% and 5 milliliters of the 15%. Cool, so that is chapter 2. What I'm going to be doing is I'll be posting this video too, and basically I'll be just giving you exercises where we have examples that are really similar to the ones that I'm showing on the videos. Okay, again, if you have any questions on this, just go ahead and send me a text message or an email and I can go over this with you, okay?